Hello student. Today our topic is belong to circle theorem. Is the second one. The definition of the theorem is says angle in a semicircle contain 90 degree. First of all, I can draw a circle here. That's the first theorem was if any angle on circumference, this is an angle, and the angle at its center point is twice. If we are drawing two angles, one from a center point and one for the circumference, this angle is double the angle of that one. But if you are drawing the same point, if we are raising one point from going there, coming like there, so now you can see it's a make a half of the circle. If I raise these one and this one also, now you can see this is making a semicircle. If this is a semicircle, then it's mean this says that they contain a 90 degree angle, or must be a 90 degree angle from here to this point and this point. So that point making 90 degree because it's linked to the first theorem, where they said that the angle at its circumference is twice an angle at its center point. If this is a center point, if we are making or counting this angle, then you can see this angle is making 180 degree. So this angle is making a 90 degree. Though, so that's 90 degree is half the angle of at its center point. But the theorem says that angle in a semicircle contain 90 degree. Whenever we draw a circle, so we can draw, we half that circle and select any of the point on any circle. If I draw in here, then you need to join these 2 points. So we can say that this is making a 90 degree angle. Whenever this triangle comes up, so easily you can find out the value of that angle. You can say that if they said that can you tell us reason, so then this is our reason for different questions when it comes in exam, so you have to give a reason. So we will go to our exam based question and that will clear more. This is our question. A, B, C are point on the circumference of a circle and the center point is O. AC is a diameter. AC is a diameter. They said that write down the size of angle ABC. We need to write down that size of that angle. Second, give reason. You have to give a reason. First of all, this angle, before that property, we know that angle in a semicircle contain always 90 degree. And our reason, angle in semicircle contain 90 degree. This is our reason. The third theorem says angles from same arc at circumference are equal. You need to select an arc. Arc is like we're selecting, this is our arc. on circumference. I just dark this one to make it more prominent. So this is an angle at the same arcs. If we are selecting any point on here, and then you are making an angle with this and that, and you have this making an angle A, for example. If you are selecting another point here on the same point, on same arc, this is angle, for example, if you write down B. If you draw so many angles but only you are using these 2 points, then it's mean they said that angles from a same arc at its circumference are equal. So A angle must be equal to B. If A is 30 degree, then this is also a 30 degree. If you draw another one on the same points, and this is also a 30 degree. So this is our definition. If any question comes like that, so you can say that angles from same arcs at circumference are equal. The fourth one says that opposite angles in a cyclic quadrilateral add up to 180 degree. If I draw a circle, and cyclic quadrilateral means 4-sided shape is called quadrilateral. This is 4 angles on its circumference. This has the opposite angle. This angle and this angle. If you are adding both angles, then if I give the name of that angle is A, that is B. If you are adding A at B, they will be add up to 180 degree. Same as it is if that angle and that angle. If this is C and this is D, so C at D is also add up to 180 degree. This is obvious. If these angles, when you adding, it's not equal to 180 degree, then it's mean this is not a cyclic quadrilateral. So sometimes the questions come in exams, they were asking, is this is a cyclic quadrilateral? If they are giving, for example, I've give an example, if I write it on angles name, if I write down in here like that becomes 95 degree, and this is, and if I say that 95, and that becomes 84 degree, like that. So when we are adding both angle, so 95 opposite angle, 95 degree and 84 degree, when you adding these values, that will become 179 degree, which is not equal to 180 degree. So we can say that this is not a cyclic quadrilateral. So this is 2 marks questions. They always comes in exam. So whenever it comes, so now you know that how to solve that question. The 5th theorems is belong to alternative segment theorem. Just like the definition of that theorem is the angle between a chord and a tangent is equal to the angle in the alternate segment. Just like I draw a circle, so this is our center point. What is a chord? Chord is like you are cutting anything like that. This is called a chord. What is a tangent? Tangent means is any line is passes through its circumference is called a tangent. So if the tangent is passes through here, so we draw any chord from here till here. They said that if we are drawing that value, now you can see that this is a chord and this is a tangent line. This angle will be equal to its alternative. If I draw any line here and making like that, so now angle between chord and a tangent line, this angle, if this angle is A, its alternative segment is that. If this angle is A, then this is also a A angle. If we are drawing angle with this chord, if this angle is B, alternative angle is B there. So the definition says that the angle between a chord and a tangent is equal to the angle in the alternate segment. Whenever the triangle lies, these are the chords. You can see that the chords, and this is a tangent line. They could be anywhere. So angle between chord and a tangent line is equal to alternate segment. Same as it is, angle between chord and tangent line is equal to alternate segment. The sixth theorem says that a tangent, this is a tangent line, and a radius always from a center points. Tangent and a radius, if they both are touches this point, then this makes always 90-degree angle. So radius and a tangent meet at 90-degree. So this is a 90-degree, or either way this side also a 90-degree. And then this is tangent is a straight line, and then that makes 180-degree. At a straight line angle is 180-degree. So, but the definition says that a tangent and a radius meet at 90-degree. The seventh one says two tangents to a circle from the same point are equal in length. If you draw any point in here, for example, this is our point, is called P point. From that point, if you draw one tangent passes through here, and we draw second one passes through here, so these are our two tangent. These are our two tangent points. So length, if I says any name of A, this is B. From P point till A, PA length is equal to PB length, because they are equal in length. This length equal to that length. And second thing, previous theorem we know that tangent and radius, these are the radiuses, isn't it? They are making 90-degree angles also. So now you can see that. So our previous theorem and this one, they all looks like a similar, but then extra thing says that two tangent now. Before was a one tangent. So two tangent from the same point are in equal in length.